Log on, tune in, find out. Another good idea from Cambridge.
Thank you very much, and also thank you to the organisers for inviting me to talk. My background, I'm very much on the user community. The community I guess I'm representing to some extent today is the Agricultural Research for Development community. My background is in farm management and agricultural economics, so there would be some people who would say that's sort of a scientist, but it's certainly not anything to do with climate science. It says in the abstract my affiliation is University of Copenhagen, which isn't quite right. I'm actually mostly associated with ILRI, which is the International Livestock Research Institute, which is based in Nairobi, Kenya. But I'm also affiliated with a program called Climate Change, Agriculture and Food Security, which I'll talk about just a little bit at the end if there's time. What I'll talk about for the next few minutes, just a little bit about developing country context, but I imagine there will be very little there that's very new. And then something about climate and weather data needs from the community that I'm part of in terms of historical information for the present and for the future and projections. And then something on challenges relating to climate and weather data, particularly related to the development issues that we're facing and that were outlined so eloquently in the previous presentation. So in terms of the context, again, you will all know this, global population is projected to reach 9.2 billion or just under in 2050. And in sub-Saharan alone, that's an extra billion people basically from now until the 2050s. At the same time, this population is urbanizing very rapidly. And in 2008 was a watermark year. For the first time in human history, more people are living in the cities than they're living in the urban areas. At the same time, there are some developing countries where income per capita is growing. And as that happens, then tastes and preferences for food change, and this will have big impacts on the demand for livestock products in the future, for example. And even within developing countries, there are very large differences between what's been happening recently. On the left, this is South Asia, and this shows cereal yields, tons per hectare against time, and poverty incidence on the right-hand axis. And you can see in South Asia that basically agricultural yields have still been increasing and poverty has been coming down. Now that's not to say that there's any sort of necessary great relationship between the two, but it's instructive. And on the right, this shows sub-Saharan Africa, so the same thing, yields at the bottom, which are just going along around about 1 ton per hectare like they've been for about 30 or 40 years. And at the same time, the poverty incidence hasn't really decreased. And then I quite like this graph because for me it really summarizes why the whole climate change issue is so important for many of the countries in the developing world that have economies that are highly dependent on agriculture. And so this shows on the this is, again, time here. This is the percentage change in rainfall, so rainfall variation around the mean in the yellow. And then on the right-hand side, this is the change in GDP, this is GDP growth. So this is for Ethiopia. And you can see the relationship between rainfall variation and GDP growth is really quite strong. And you could do this for many countries that have economies that are highly dependent on agriculture, and you would see the same kind of thing. And so this sums up why climate change is so important in many developing countries. And so the issue then from a development context is how can we achieve food security and maintain or enhance livelihoods in the faces of these, not only climate change, but climate change as part of this package of stuff that's facing many developing countries. So that's the sort of just a few words about the context. Just a couple of examples on our needs for climate information. So this is just an example of this is a sort of a bog standard project that we were involved with in Ilri, we're looking at, or just trying to find sort of just testing different alternatives that that farmers can try out. So given the objectives of farmers, and by the way, finding out what farmers' objectives is not an easy job, but are there better ways that this particular work was done up in Western Kenya, which some of you will know, the land area per household is actually very small, and it's declining largely because of the way that the inheritance works. So given farmers' objectives, are there better ways to allocate land so that you can improve household incomes and household food security? So this involves doing things like field data collection, and then working with farmers to evaluate some of these different alternatives. And we use things like agricultural impact models, so crop models and livestock models. And again, many of you will be very familiar with these. But of course, to run these things, then we need a whole set of input information, but some of these are historical daily weather data, so that we can evaluate and calibrate our crop and livestock models, so that we can look then in particular situations characterized by particular climate, particular soil conditions, particular socioeconomic conditions. Then we can then look at how the options or particular options may actually work. And then again, in this particular example, we're looking at things like can we keep, or rather than manure just being spread on the farms, on the field, are there ways to store it so that you can then reduce the loss, the nitrogen losses to the atmosphere? Can you do the same with, can you actually collect cattle urine and use this as something to fertilize different plots? I mean, this is the details don't really matter, but it's just to do this kind of work, we have to have good idea of what's happening in terms of weather and climate. And if we're going to use models to look at some of the biophysical impacts, then we need high quality weather data. And okay, another reason that we, in this particular project, these areas in purple that you can see here, these are really the domains that match the characteristics of the place where we're actually working. So in this particular case, these are the mixed rain-fed, humid, subhumid crop livestock systems with medium human population density. And so this shows a map of the regions of East Africa that have those similar conditions. And the point being, if farmers are actually taking on board and adopting some of these options, then it may be worth going to some of these other places which have similar agroecological characteristics and seeing if we could maybe there'll be farmers in these other places that would also adopt these kinds of alternatives. But again, for this kind of thing, we need very good historical weather data. The previous speakers mentioned seasonal forecasting, and in terms of sort of what's another need for climate information would be for information on seasonal forecasting. And so this is Africa, and these are regions of sub-Saharan Africa where seasonal precipitation can be simulated with reasonable skill. So this is a map from the IRI and the OND, JFM. These are the months of the year that more or less correspond with the wet season. So you can see that there are already areas where there is some skill in predicting seasonal totals. And again, many of you will be aware of it. This is again from the IRI, and they produce these kinds of maps that give you an idea of whether in the coming few months, whether above normal or below normal rainfall is going to be expected. And then the point, of course, is, as was already made clear in the question to the earlier session, it's fine having, you may have a skillful estimate of your seasonal rainfall total, but the issue is, well, what can you do about it? This is some quite old work, but these are coping strategies used by farmers in semi-arid West Africa. So of course, if you're looking at the time frame from pre-season, then there are all these things that farmers could do. If you know the coming season is likely to be either super wet or super dry, there are various things that could be done. You might plant different type of crop. You might plant a variety that's been bred for stress tolerance, for drought tolerance, for example. And so you can see that these various scales up to the household or the village, there's quite a lot actually that could be done if farmers had forewarning of what the current season is likely to be. And so you've got two of the three things that you need. One is you need some sort of prediction that has some skill. The second thing you need is farmers obviously need to have options and be able to take on board some of these different things. And then the third thing is how can you actually facilitate the use of the seasonal predictions so that would actually enable farmers to be able to make some of these choices. And of course that's why it's quite a challenge, and there's still quite a lot of work that needs to be done on the institutions that can enable this these kinds of forecasts to actually be used. And then we have a need for climate information for the future. And again, I don't want to spend very much time on this, but just looking at, we've done a bit of work taking GCM data, downscaling it in what's probably again, we're not climate scientists, but we've taken GCM data and downscaled it, and then run it through various agricultural impacts models to try to get some idea of what may happen in terms of simulated yields. We were looking at sub-Saharan Africa under current conditions and then out into the 2090s. This was for a recent conference last year, looking at what may happen to agriculture in Africa with a sort of a 4 degrees or plus 4 degrees. And then we came up with some estimates of changes between now and the 2090s. And this is using an ensemble of about 18 different climate models. But I mean, I think that the point here is that for some of these crops in some of these regions, if you look at the between model scenario variability of production, then some of these coefficients of variation are actually quite small, which would suggest or start to suggest that you're looking at quite a robust result. Whereas there are some others where these coefficients of variation, so a measure of the between model variability, are really quite high, in which case then, I mean, this, in many ways, this highlights part of the problem that was talked about in the previous talk. Then if your results are then going to depend on your choice of GCM and emission scenario, then where does that leave you? How can you then talk in a meaningful way to decision makers who need this kind of information? And so, just finally, a few minutes on what are some of the challenges. This is some work that was done just quite recently, looking at some of the constraints to climate research in the region. This is the Greater Horn of Africa, so this is a large part of East Africa. But I suspect in many developing countries, you would, if you did the same in other places, you would find similar sorts of challenges. So this would include lack of climate data, lack of historical climate data. There's problems with capacity building, there's problems with funding, access to literature and sources and internet capacity at the institutional level. Now in East Africa this is changing quite rapidly, even in the last couple of years, but even so it's still an issue. There are also gaps in regional climate data, so knowledge of the basic climatology, providing reliable data for climate monitoring and spatial coverage of highly variable areas, because of course, as many of you will know, the spatial variation in East Africa climate is very large. And then also lack of observational climate data being seen as a sort of a major constraint to understanding what's happening currently and particularly what may happen in the future. And there are also issues associated with downscaled GCM data. So again, this has already been mentioned. Can we get information at appropriate temporal and spatial scales? What about its availability and accessibility? Are we getting, in terms of if we're doing agricultural impact modeling, do we get the right variables that we need? Is it in a format that we need? And we shouldn't underestimate the problems of getting data in a format that many people can use. For sort of old people like me who can write Fortran, that's fine, but there are many people in national programs in developing countries who don't have that capacity, and so then the thing of sort of what format data is in then becomes a huge constraint. And then evaluating and comparing different methods. One thing I'm particularly interested in is this issue of, does the method in which you do the downscaling actually contribute to the overall uncertainty associated with what you get out of agricultural impact models? Because it may be that there's so much uncertainty anyway that actually your downscaling methodology may not actually add that much. I don't know. I mean, I think that's a sort of researchable question that we're starting to try to look at a little bit. And then again, this is probably a common issue. How can we communicate uncertainty appropriately to decision makers who need to make resource allocation and other types of decisions? And I mean, this is completely obvious, but the importance in developing countries with economies that are highly dependent on agriculture, climate information is absolutely critical. And it's, as already mentioned, there's enormous spatial heterogeneity. The impacts and the responses, as far as we know, they seem to be highly dynamic, often non-linear, and climate and other shocks can affect power, governance, and equity relations that can disadvantage the vulnerable. And we absolutely need climate information to quantify impacts and responses. These that may arise both from changing means and changing variances. I mean, I think that's particularly important in the agricultural sector in many countries. Changing means is one thing, but the changing variances and how the variability of whether it will change or may change in the future and the impacts that will have at the household level. And from the agricultural side of things, that's a huge area that's really, we've only just starting to look at, and it's extremely important. And then also another very sort of practical issue, historical data is critical to understanding how households have dealt with risk in the past. And there's a sort of growing recognition that if you're going to work with people who are already quite highly exposed to climate and climate variability, then those are good people to work with from the adaptation side, because there are probably lessons that can be transferred from one place to another, so to help other people also deal with increased risk. And just to say a little bit about the program that I'm now associated with, climate change, agriculture, and food security. This is a sort of a marriage of two communities that in the past haven't really talked to each other. One is the CGIAR, the Consultative Group on International Agricultural Research. So these are the international centres that are dotted through the, mostly in developing countries that are working on, and they started off as breeding centres but are now working in sort of much broader sort of natural resource management areas. And then the Earth System Science Partnership, which is made up of four of these four big global change programs. That's Diversitas, IBGP, IHDP, the Human Dimensions Program, and the World Climate Research Program. And so trying to bring these communities together, and so that the agricultural community can then make sort of the best use, or at least get access to sort of cutting edge climate science and then use it as applicable. And there's a website that describes, this is a very new program, it was started this year, and this will be expanding next year. But from the agricultural user perspective, this is one way, one mechanism of hopefully getting much better climate science actually involved into the problems of agriculture and agricultural development. So I'll stop there. Thank you.
Can I just get you to clarify what future time horizons are you most interested in this area? So we heard in some of the earlier talks today that sort of 3 to 4 years, up to 10 years are probably the sort of the most useful timescales. Is that the same for you as well?
I would say I think we need to be involved with sort of both the short and also the long term, because a lot of work in agricultural science, or there's quite a lot of work on breeding crops for increased drought resistance, increased heat tolerance, for example. And even using sort of fairly modern genetically based techniques that I don't pretend to understand, there's still quite a long time lag between sort of developing new varieties, and they've got to be tested, and then if you're going to release them in a country, they've got to be certified, and that whole process may take, I mean, even sort of using sort of shortcut breeding techniques, it still may take 10, 15, in some cases 20 years. So there's a big time lag that we have to be thinking about. So I mean, I think you can see we do need to be obviously concerned with sort of what's happening over the long term, but also very much also what's happening over the short term, and the whole issue of, can we help farmers deal better with the current levels of risk, of climate-related risk that they're facing, on the basis that we don't know very much about how those risks are likely to change in the future, other than it's going to get more risky probably in many places. And so if you can then do something to help farmers adapt better to current levels of risk, then they may be better they may be able to cope better in the future. So I think, I mean, the answer is I think we need to be looking at the sort of the full spectrum.
Very nice presentation. Actually, I am also working related to the same concepts. I'm from India. I'm working on network project on climate change to Indian agriculture. We're also doing impact assessment, adaptation, and vulnerability. Did you quantify any adaptation strategies through decision support system, and did you find any vulnerability levels for particular crops? Actually, it's shown in west side, it is minus 43% of reduction. Did you tested any adaptation strategies using some varieties and date of sowing? Did you find what are the levels of the adaptation strategies, and did you quantify any vulnerability levels?
This is a good question, and it's something that actually we need to do. We haven't done very much of that, and I think in many of these systems, trying to identify what are the limits to adaptation from sort of, if you like, conventional sources now, or are we going to be will there be some places where even with sort of fast track breeding programs, maybe we can't do very much about heat tolerance in rice, for example. And I mean, in East Africa, of course, maize being one of the staples. I mean, the fact is, if you can grow millets and sorghums in places where maize won't do very well because they can cope better with drier, hotter conditions. But the fact of the matter is, people in East Africa, they don't like to eat millets and sorghums. They like to eat maize. And so then you've got some sort of, you have these sort of the whole sort of cultural preference issues. But ultimately there must come times when you're going to hit the sort of your boundaries of what can or how can farmers adapt in a way, and ultimately you may have to start thinking about, well, some farmers are going to need to think about other livelihood options so that they can actually sort of deal with what's likely to be coming in the next couple of decades. But I think identifying where are the limits to adaptation, and I think it's an extremely important question, and obviously it's going to be very dependent on the site and the socioeconomic context. But there's a lot of work that needs to be done, because I think that's going to be, again, if I was a national policy maker coming up with your adaptation plans, then it's very important that you have some idea of what can you expect to get away with through adaptation, or where are you going to have to take a sort of a much more radical approach to try to deal with the risks in the future.
It's very needed to prepare a low-cost adaptation and high-cost adaptation actually to the country. So it's very needed information. And I would like to put one important point. Actually, when we are using different DCMs and RCM as input for crop growth simulation model and to estimate the impact assessment, you will get different reduction levels in different models. That's why I would like to, it is a great challenge for our community, climate science people. We need to quantify the uncertainty for each model and weakness and strength of each model. And you have to utilize that information for each and every sector. Suppose some models having the different level of complexity. Some models are using only atmospheric model. Some models are using coupling ocean and atmospheric. So each and every model should have the capability where we can use in which sector. That is more helpful when we are going for decision support system. Thank you.
Sure.
So, I guess my question was about how much work there is on a more complete approaches. I really appreciate what you're doing on crop yields, but I may have misremembered this slightly, but in the story in Ethiopia in, say, around 2000, you have pastoral people whose livelihoods is very linked to their cattle, and there was a Rift Valley fever outbreak that decimated the cattle. Then there were knock-on impacts into the economy, and it really disrupted their livelihoods in a profound way. So in that case study, at least, it seemed you needed to think not just about the cereals, but also about the cattle, and also about the economic system, which got kind of imbalanced by ultimately things that could be partly at least traced back to climate.
Right.
So I'm just curious as to the state of the science on, beyond just the crop yields, which I think you're doing really well on, a more complete picture, because as I understand it, some of these people in East Africa's livelihoods is more complex.
No, I mean that's a good question, and I think if you look in the sort of the IPCC or even some of the sort of the global assessments, they do tend to be very crop orientated, and I mean I think there are sort of good understandable reasons for that. But of course, in sub-Saharan Africa, particularly, many of the, as you've said, most of these smallholder farming systems, they have almost all of them have livestock in some form or other. And for many poor people, they're a key asset, and when times get hard, they're a form of cash and all the rest of it. I mean, and so I work with a livestock institute, and so we're really trying hard to look at what are the impacts at the household level. So households that may be agro-pastoral, or they may be sort of more mixed systems, but trying to look at the systems impacts of climate change impacts on both crop and livestock yields. And of course, in many of these systems, there are sort of really big interdependencies. So, for example, in some of the more semi-arid systems, then the residue, the leftover stuff that's not the grain, it's a critical dry season feed for many of these households. And so, of course, if you're going to get impacts on production or nitrogen content, which may change the quality of the feed, and these things may have really important impacts. And so that's, I think you're right to highlight the need that we really have to look at these things at the sort of the systems level, to really make sure that we're getting good information as we can on what the system level impacts may be, because just by focusing on the sort of even the staple cereals, we may be missing a lot of the what's really likely to be happening in the future.
Okay, thank you very much. And someone seems to think it's